Good morning everyone. So today here we come again with the same topic, area of the parallelogram and triangle, part 2. So in last class we studied about that when the two parallelograms are having the same base and in between the parallels, then the areas of these two parallelograms are equal. Now we will study that if there is a triangle and the 3 points are the midpoint of their corresponding sides, then what will be the relation between these triangles. Okay, so here we go. As we can see here, ABC is a triangle in which DEF are the midpoint. What are these points? These are the midpoint. As we can see in this example, DEF are respectively the midpoint of the sides BCCA and AB in the triangle of ABC. So now we have to prove that BDEF is a parallelogram. Where is BDEF? Here, BDEF. We need to prove that this is a parallelogram first. Okay, so here we go in the solution. The first part is BDEF is a parallelogram. So firstly we will give that what is the given point in these conditions. The given points, you can write it that ABC is a triangle, so you can write it ABC is a triangle, as well as D, E and F are the midpoints. Midpoints of sides AB, BC and AC respectively. Okay, now if these are the midpoints, so can we say that AF is equals to BD, BD is equals to CD, CE is equals to AE, right? So these are the given points. Now what to prove? You can write in that condition to prove all these three cases, you can write it there. Okay, after that no construction part is there, so you can write it at last what you need or how to prove this statement that the BDEF is parallelogram. So we can apply a parallelogram property in that if BDEF is a parallelogram. So how to prove that these are the parallelogram? Look at here. So firstly we know that D, E and F, these are the midpoint of triangle ABC, side AB, BC and AC. So if these are the midpoint DEF, so can we apply the midpoint theorem? Yes, as we know, we studied well that if we join the two midpoint of the triangle, like here AB midpoint is F, AC midpoint is E. So if we join the two midpoints of the triangle, then it will be parallel to the third side. It will be parallel to the third side. So that statement we can write it here. As we know that in triangle, you can write that also. First, in triangle ABC, we know that F and E are the midpoints. Let's take it here on the next. Okay, so I have to draw the figure again. Here it is A, B, C, D, E and F. So as we know that these two are the midpoints. So in the triangle ABC, F and E are the midpoints of AB and AC. So if these are the midpoint of AB and AC, what does that mean? It means EF will be parallel to the third side, which is BC. So that we can write it here. That means EF or FE is parallel to the third side, which is BC. This is the sign of parallel, and what we call it? It is midpoint theorem. Okay, we all know that if we join the midpoint, then it will be parallel to the third side. So that means we can say that EF or FE will also be parallel to BD, because D is also the point on side BC. So if FE is parallel to BC, that means FE is also parallel to BD, right? So you can give the equation also. Now second thing, in the midpoint theorem only, if we join the midpoint of the triangle ABC, then it will be parallel as well as half of the third side. So, and we can write it here, FE will be half of BC as well. So if FE is half of BC, and we know that BC is also equals to BC is half of BC means, just wait, half of BC. So if D is the midpoint of BC, that means we can replace this half of BC as BD. Here we can give the reason, because D is the midpoint. So if D is the midpoint, that means BD is also equals to DC. That means half of BC is BD, right? So that's why we have written here half of BC is BD. So here we proved it that FE is parallel to BD as well as FE is equals to BD. So now we can prove that, we can write it thus. We proved it that if one pair of opposite lines are parallel and equal, okay, so when this kind of thing in a quadrilateral, when one pair of opposite sides are parallel and equal, that means a particular quadrilateral will be parallelogram. Okay, so we can write it here thus: one opposite pairs of a quadrilateral are parallel and equal, so it is a parallelogram. Although we know that both the pair of opposite parallel lines, both the pairs of opposite sides are parallel and equal, but in that case, if one pair of opposite lines are parallel and equal, why I am giving the stress on and? Because if these pair of lines are equal to, then the other remaining two pairs of lines are also become parallel and equal. Okay, so when these two things together, that the two lines, opposite lines are parallel and equal, then the quadrilateral must be a parallelogram. Is that clear? Okay, all right. So if these lines are parallel and equal, that means we proved that BDEF is a parallelogram. All right, now so here we proved it, BDEF is a parallelogram. Now we move on to the second part of this question, which is area of triangle DEF. Where is the triangle DEF? The center one, DEF. Is this triangle area is 1/4 of the full triangle ABC? Isn't it? We can look here, 1, 2, 3, 4. There are 4 triangles, so maybe it's looking 1/4 of the full triangle. But how to prove it? Why the full triangle is equals to 1/4 of half of the center triangle DEF is equals to 1/4 of the triangle ABC. So Now here again, let me take this color now. Again we draw the triangle ABC, and here is the triangle DEF. Now this time we need to prove it. We are doing now second part of it. We need to prove it that this triangle or area of triangle DEF is 1/4 of area of triangle ABC. All right. So now we know that if in a parallelogram diagonal bisect into two equal triangles, right? So as we can see here in this parallelogram BDEF, FD is a diagonal, BDEF, this is a parallelogram, and FD is a diagonal. So we can say that in a parallelogram diagonal bisect parallelogram into two equal triangles. They are congruent, we can prove it already, yes. So we can say that these two triangles are equal in area, so as these two triangles. Okay, so that statement we have to write it here. What we know that in parallelogram BDEF, in this parallelogram BDEF, DF or FD is a diagonal, so that we can say that area of triangle BDF is equals to area of triangle DEF as well. Okay, triangle number 1, triangle number 2, areas of these two triangles are equal, so we can give the name equation number first. So similarly we can say in this case also DCEF is also a parallelogram, correct, and DE is also a diagonal. So that means triangle number 2 is also equals to triangle number 3 in the terms of congruency, in the terms of area, they are equal. So we can write here as well. So similarly you can write it the whole process again, that D or CDFE is a parallelogram and DE is a diagonal, so that it's divide the parallelogram into two equal triangle again. So I'll write it similarly. In parallelogram DCEF, we have DE is a diagonal, so that we can write area of triangle CDE is also equals to area of triangle DEF, and this is our equation number 2. Okay, now we prove that 1 is equals to 2, 3 is equals to 2. So what about this? Can we write it here, triangle number 4, and this 4th is also equals to 2. How? Look, similarly we can write it here as well. This AFDE is also a parallelogram. We already proved it because this is half, so this is also half of the side, this one. So similarly we can say in this triangle as well, area of triangle AEF is also equals to area of triangle DEF by the same way. So you can give it the equation name, equation number 3rd. All right, so now from equation 1st, 2nd and 3rd, what is there? DEF, DEF, DEF. That means if in all these three equations DEF, that means all these three equations are equal. So that means we can say in this triangle, full triangle ABC, in the full triangle ABC is formed by the sum of these small triangles. So I'll write it that area of triangle ABC is equals to area of triangle. First we will take this triangle AEF plus area of triangle BDF plus area of triangle DCE and plus area of triangle DEF. Okay, so as we know that the full triangle is formed by these four small triangles, so as we can return here, area of the full triangle ABC is equals to sum of these four triangles. Now we can write that also AEF, this triangle, BDF, here it is, this triangle, and DCE, where is DCE or CDE, they are equal. So all these areas is equals to DEF only. So can we replace these all three by DEF? That means in this triangle we can replace it by DEF. This triangle is also replaced by DEF, and DCE is also replaced by DF, or you can write it CDE also here. So I'll do that. I replace it that one by CDEF. So that all these three, now count it 1, 2, 3, and it is already fourth one. So can we write the fourth area of triangle DEF? Is it right? Here on the right side, ABC is equals to fourth of area of triangle DEF. Okay, and that means we can write it area of triangle DEF is equals to, when fourth is transposing on the left side, it becomes in a denominator, it's going in a denominator. That means we can write it 1/4 of area of triangle ABC. Is it right? So in the second portion we have to prove only that much. 1/4 of area of triangle ABC is equals to DEF. 1/4 of area of ABC is equals to DEF. All right. So now we prove the second portion also. Let's go for the third one. And the third portion is area of BDEF. Where is BDEF? The same parallelogram, is equals to half of the area of the full triangle ABC. Is it half? Look at this. BDEF is half of the area of the triangle ABC. So now in the last third portion we need to prove that. How is it? Let me take this. Here is your triangle ABC, and these are the midpoints. We can join it and make the triangle DEF. These are the midpoints. Okay, so in this part we have to prove that area of parallelogram BDEF is half area of triangle ABC. Okay, so now we are comparing the parallelogram by a full triangle ABC. So in this case also we can say that similarly this full parallelogram, this is a parallelogram, so we can find out that this FE is already parallel to BC as well as FE is equals to BD. So now we can say that if AF is equals to BD, AE is equals to EC as well as BD is equals to CD, we already proved that these all four triangles are equal. in the second portion we proved it that all these 4 triangles are equal. So from there only we can take it that we proved that area of, I'll write it down so that it can be more clear. Area of triangle BDF is equals to area of triangle DCE is equals to area of triangle AEF, as well as this is equals to area of triangle DEF. From the 3 equations which we just proved before, all these 3 equations have equal area. Triangle 1, 2, 3 and 4. If these all are equal in area, so we can say that the BDEF is formed by the twice of the triangle BDF. Okay, so we can write that in a full triangle, if you are comparing it by the full triangle, in triangle ABC, by the triangle ABC we proved it that area of this triangle ABC is, or 1/4 of the triangle ABC is equals to area of parallelogram, parallelogram area of triangle BDF. Okay, let's take this triangle first, BDF. So if we are comparing this full triangle by the single portion of triangle BDF, then this area is 1/4 of the full triangle ABC. So if it is 1/4 of the ABC, so we can say that one-fourth of the area of ABC is equals to, if we are joining these 2 triangles, then it forms a parallelogram. First one BDF, which is that, and FDE. So if we join these 2 triangles like this, area of triangle BDF plus area of this triangle DEF. So if we add this triangle here, so that in this condition here in this triangle ABC, which is actually 1/4. Now if we add DEF here, so here on the right side also we have to add it. But what we formed it after it? Okay. Like we will write it again. So this case we already proved it that area of the triangle BDF, this one, is equals to, these all are equal, so here it's left area of triangle and B portion also DEF. So in this case we can say that area of BDEF, here we already proved BDEF is equals to DEC, AEF and DEF also. So if all these 4 triangles are equal, that means if we add these 2, then the sum of these 2 also equal. Okay, so we can write it here, triangle BDF plus area of triangle DEF is also equals to area of triangle CDE plus area of triangle AEF. Okay, now the sum of these two triangles also equal, and we have to compare now full parallelogram BDEF. Now the sum of these two triangles makes a parallelogram. Area of sum of these two triangles first and second, they make BDEF. So we write it here, BDEF is equals to area of the triangle CDE and AEF. So instead of these two, can we write the sum of these two as well, because this triangle is also equals to this one, right? So if the sum of these two triangle is equals to the sum of these two triangle, so we can say that this is the, if we are comparing it by the full triangle ABC, then it will be the one half of the triangle ABC. Look at this, CDE and AEF. CED is this one and AEF is this one. So triangle number 3 and 4, the sum of these two triangle is equals to exactly, or you can if you go in the second portion, we have written that the first, this only one, this is 1/4 of area of triangle BDE or BDF, that we proved already in a second case, that only the single one, this one CDE, any one triangle out of these four is 1/4 of the full triangle ABC. So that concept we also wants to include in this first third portion, that area of only the single triangle FDE is equals to 1/4 of the area of the BDF. Similarly, this is also doing the same thing, 1/4 of the area of triangle BDF. Although you are taking you can take any one out of them, you can take it DEF also, CDE also instead of BDF. So now from here we can write that area of this parallelogram BDEF is equals to, the same things comes together, I mean twice, so you can write it twice of 1/4 of area of triangle BDF. Okay, now we can just cancel this 2 by 4 2 times, so it comes 1/2 area of triangle BDF. Can we write this BDF as replaced by any one of them? BDF, where it is this one. So just wait, what's wrong is there, 1/4 of the triangle one, yes, here we have done the mistake. Instead of that, we have to write the full triangle ABC. This is compared to the full triangle as ABC, so triangle here ABC. So similarly you have to replace it from here as well. ABC. So now area of the triangle ABC. All right, so now we have proved it that area of parallelogram BDEF, this area of the parallelogram is half of the full triangle ABC, and that's what we want. Look at this third portion, area of the parallelogram BDEF is equals to half of the area of the triangle ABC. Okay, so here you need to be careful that whatever you are taking the triangle is compared to the full triangle ABC. All right, let me explain it again. we proved these 3 points. First, BDEF is a parallelogram. So we proved it that by the midpoint theorem, if F and E are the midpoint and we join it, then it will be the parallel to third side of the triangle BC, as well as it is half of the third side. So in this case, FE is going to be parallel BD, as well as they are equal to. So that means if one pair of opposite sides are parallel and equal, then the parallelogram or quadrilateral will be a parallelogram. Then we proved it that the triangle DEF, this triangle DEF is parallel 1/4 of the triangle ABC. So in that case, we proved it that this DEF is a half part of the parallelogram BDEF, and in that way this triangle is coming equals to this one, as well as this triangle is also coming to equals. Therefore this is also coming to equal. So that means these are actually the 4 triangles which are equals in area. So that means if we are comparing this only one portion to the whole triangle, then it comes 1/4. So that's written here, 1/4 of the full triangle ABC. Then the third part of that, BDEF, this parallelogram is half of the area of the triangle ABC. So if you want to prove it these two, so you can add these two triangles, which is actually the sum of these two triangles. Or if you want to prove it by the full triangles, then in the full triangle these type of triangles are coming 4 times, and the twice of this triangle will be equals to these two. So when the twice is equals to the full triangle, then 2 will cancel by 1/4, as we already proved it, area of one triangle, any one out of them is 1/4. So it comes half of the full triangle ABC. All right, hope you like it. Thank you very much. Goodbye.